Hi, and a very good day. So, for this particular video session, I will explain about reading raw data files in SAS. Okay, so in this chapter, we are going to explore how SAS can read data directly from raw text file. Okay, sometimes called as flat files or CSV file, and then we will convert these raw data files into a proper SAS dataset. Okay, the difference between this chapter and previous chapter, the previous chapter we deal with Excel spreadsheet, and now we deal with raw data files. So for this particular chapter, we will have four sections. We will begin with section 8.1, introduction to reading raw data files, and then reading standard delimited data, and next using formats to read delimited data, and lastly handling missing data. So this video we will cover 8.1 and 8.2. All right. These two objectives are very straightforward for this particular section, 8.1. We will begin with 8.1. First, you should be able to identify the different types of raw data files and the different input style that SAS used to read them. Second, you should be able to define what we mean by standard data versus non-standard data. These two concepts will be fundamental to everything we do in this chapter. So make sure that you understand this particular concept. All right. So let's take a look at the business scenario. So for this particular scenario, the Orion Star Sport and Outdoors company has information about their sales employees from two countries, which is Australia and the United States. But this employee information is stored in a raw data file rather than in an Excel spreadsheet or a database. So as a SAS programmer, you need to be able to look at that raw files, understand its layout, and write the SAS code to read it correctly into SAS dataset. Okay, so let's take a look at the definition of what is raw data files. I believe that if you are familiar with others programming language, this is actually an important skill that you need, because um, commonly we will find that the data will be stored in this particular data format. So a raw data file is also known as a flat file. It is actually simply a plain text file. And when you open the files, you will see that each line in the file represent as one record. Okay, or another else, the term is observation. Okay, think of one row of the data, and one row data is one record. So each record typically contains multiple fields, which are the individual data value for each variable. It means that for a single record, you will have different variables, and they will have values in that particular variables. An important characteristic of flat files is that they do not have internal metadata. That means that the file itself does not tell you anything about the structure of the data. Okay, but commonly there will be a record layout, which is a separate document that describe the fields. Okay, what each field contain, where it is located in the record, what type of data it is, and how wide it is. Okay, so a record layout describe the fields and location within each record. Okay, so let's take a look at this particular examples. This is uh, the common raw data files that can be either delimited or arranged in fixed columns. So this is actually two different types of raw data files. One is separated by the delimited. This is example delimited by comma. And the raw data file also can be arranged in fixed column. Okay, as we can see here, based on this column ruler, every every entry for the variable will follow the same length. Okay, so you can take a look at the raw data files to make sure that which raw data files that you have. And SAS actually can read both type. Okay, but the input style that we will use will be different depending on which raw data files that we have. All right. And when we write SAS code to read a raw data files, we actually need to tell SAS three things about each field. Okay, first, the location. Okay, the location of the data value in the record. Okay, where does this field begin and end? Next is the name of the SAS variables in which to store that data. And third, the type of the SAS variable. Okay, it is numeric or character. So these three pieces of information are what we will specify in our input statement. Okay, this is why the record layout document is so important. Okay, so uh, let's take a look at this one. Okay, there are different techniques or input style for reading raw data file in SAS. We can have column input, formatted input, or list input. So for column input, this will be used for standard data arranged in fixed column. As example, this one lah. Okay, so example this one, the fixed column files here. So we will use column input. Next is formatted input. For formatted input, it is used for both standard and non-standard data in fixed column. Okay, and lastly, list input is used for standard and non-standard data separated by blank or some other limiter. So, as example here, this will be we will use list input for this particular files rather than the column input. Okay. So this is uh, the distinction between standard and non-standard data. Okay, standard data is data that SAS can read without any additional instruction. Character data is always standard. SAS can read any character string as examples. Okay, for numeric data, many common forms are standard. As example here, the plain integer 58, decimal numbers like 67.23, negative numbers like minus negative 23, scientific notation like 5.67 E5, and leading zeros such as 00.99. So this is all standard examples. Okay, however, some numeric data is non-standard. As example, they have dollar sign. Okay, they have parentheses. Okay, parentheses to show the negative value. So this is non-standard, and also numbers with embedded commas like this one, and dates in any format. Okay, so whether you write it for particular date, whether you write this way or this way, okay, date values are always non-standard in SAS. So we will need to use in formats to handle non-standard data, okay, which we will cover in section 8.3. Okay, so make sure that you understand this difference between the standard and non-standard. Okay, so let's take a look at this quick poll. The question is, what type of raw data files do you read? Okay, the option are A, delimited, fixed column, both delimited and fixed column, or D, I do not read raw data. Okay, so the thing is, when you take a look at the files that you need to handle, uh, you have to take a look at uh, which category belongs to your data. Your data is belong to which type. Depending on which type of the raw data files, you will have a different way to input the to to use this input style. Okay, all right. So next, let's take a look at reading standard delimited data. Okay, so For this standard delimited data, we will take a look at this objective. Use list input to create a SAS data set from a delimited raw data files. Second, we will examine the compilation and execution phase of the data step when reading a raw data. So we will take a look at what happened behind the scene. Okay, when you compile and execute this particular raw data in the data step. Okay, and then explicitly define the length of a variable, examine behavior when a data error is encountered. So we'll take a look at this. Okay, right. So we have this particular business scenario. The information about Orion Star sales employee is stored in a comma delimited raw data files. Okay, the files contain both standard and non-standard data fields. Okay, so means that you can have mix or combination of both standard and non-standard data fields. So that's why it is important for you to investigate your raw data first, okay, to take a look at what are the data that you have. So based on this, you see that this is comma delimited raw data file. You will have this kind of view. Okay, so this is sales.csv, right? Uh, as we can see here, you have to determine, okay, which standard and which is non-standard, right? So based on this, since that date is always non-standard, so we will take a look on how to deal with this date later. Okay, and whereby the others field is the standard one. Okay, SAS can read this without you without any additional instruction. Okay, so this is the way. Okay, so you have to um, distinguish. Okay, which file can be read as standard and which files cannot be read. Okay. So as example here, which field in this file can be read as standard numeric value? The answer is the employee ID and salary. Okay. The date fields are non-standard and require special processing. So that's the answer. And then this is a data step that we will use, and uh, based on this, they use sales.csv and path. Okay, so to set up in your SAS, okay, in your SAS, for me it is easy for you to take a look at the data. Okay, the data is this is in PG1 data, and then you try to search for sales.csv. Okay, this data. Okay, so here you just right click properties and you copy this location. Okay, you copy this location and then you put this in this double quotation. Okay, the location of the file. If you want to use npath, you have to define the location. Okay, the in our last snippet. So here, if you have this %let, you can use npath here. So that's the difference. Okay, so just read this data accordingly, whatever works. Okay, so for this particular example, I use the location of the file. Okay, make sure that you are referring to the correct files, sales.csv, because we will demonstrate on how to read CSV file. Okay, so basically this is the general way on how to write the data step. So we will use in file, and then we give the location of the raw data files, and we specify what are these particular files delimited type. Okay, the special character. So for this particular example, we use comma. Okay, and then input is the variable. Since that for this particular sales.csv, we have date, and date is non-standard, so we will show the demonstration in the next section. Okay, so in file statement, identify the raw data files to be read. Okay, there are actually three important points here. First, a full path is recommended. So you need to specify exactly where the files is located. Second, using the ampersand path and path here, okay, uh, macro variable reference makes the program more flexible. If you define the micro variable and path at the top of your program, means that you put the and let path to state that this is the general location. Okay, you only need to change it in one place if the file location changes. So I believe that everyone already understand the difference between this and this one. Okay, this is exact location, and this you use the end path. Okay. Third, the DLM option specify alternate delimiters. Here we specify a single comma character, so SAS known to treat commas as field separator. Even when we take a look at this particular raw data, they use comma. Okay. And we have input statement. So input statement reads data field sequentially from left to right. So means that you will have this column following a sequence lah. Okay, employee ID, first name, and so on. Okay, so this is the general syntax. Okay, and hopefully everyone understand this. Okay, the dollar sign indicate a character variables, and the default length for all variable is in list input. Okay, for both numeric and character is 8 bytes. So this is the default length for all variable. Okay, regardless of that. And then whether we will successfully execute the data step, you can take a look at the log. The log will tell us okay how many observation that were read from the infile. This is the location, our infile location. Okay, viewing your log is important to make sure that you successfully read the data, and you can viewing the output. Okay, some character values are truncated. Okay, it means that as we can see here, sales MA they will have been truncated. Should be this is maybe sales manager and so on. Okay, so be careful when we use this kind of defaults length. So it means that for this particular job title, it is best for us if we define the format. So you can ensure that the character values are not truncated. Okay. So so that's why it is important to understand the processing that occurs when the data step read a raw data file, and this is actually how we take a look at the phase. Okay, they have compilation phase behind the scene. Okay, you can try to take a look at the this diagram to see what happened behind the scene. Okay, so we you need to understand the compilation phase which will help us to explain why the length statement must come before the input statement. Okay, the truncated problem happen because we don't put the length statement. Okay, this is the way, and so on and so on. Okay, I hope you can read through this step. Okay, and then you can take a look at the data step processing. Okay, and the most important things that I want you to understand is actually the length. Okay, the length that need to be put before this particular processes start. Okay, so this is about the PDV like I explained previously. Okay, and this emphasize okay why you need this particular length. Okay, to make sure that the character values are not truncated. Okay, you have even though that even though that in general SAS does not require us to properly put which statement is first and next and so on. But for data step, it is important for you to put the line statement first before the infiles and input. Okay, to make sure that this particular character will not be truncated. Okay, so for this particular short answer pool, suppose you want the order of the variable to match the order of the field. Okay, which of the following produce the correct result? So the answer should be B. Okay, because of what? This particular length is they specify the numeric length. Okay, so because certain ID they have a fixed length. Example as our student ID they have a fixed length for that particular numeric variable. Okay, so that's why you can also add numeric variables length in the length statement. Okay, right. So for this particular example, suppose that you already put the dollar sign in your line statement. Okay, when you use input statement, you can omit the dollar sign because for this particular statement, they already recognize this particular last name as category. So that's why in the input you don't have to put the dollar sign again. Right, so this is the examples. Okay, and this is the next business scenario. A raw data file contains information about Orion Star sales employee. It includes some invalid data value. Okay, and this is CSV. We have the data step here, and we will turn this sales tree inv.csv into SAS data set through data step. Okay, and in this particular sales tree inv, they have some invalid value. Okay, as example here we have an A. Okay, and we have suppose that we have this AU for the country code. We have 12. So this is example of invalid values. So so what happened when we read raw data file with data error? Now it will turn into missing value. Okay, SAS will turn this into missing value if you have data errors in the raw data files. Okay, so data errors occurs when the data value does not match the field specification. The following information is written to the SAS log. So when you read this particular fields, input files, and then you take a look at your log, you will have this error. Okay. Okay, two temporary variables are created during the processing of every data step. Dot n underscore n underscore is the data step iteration counter, underscore error underscore indicate data error status. So this will tell us zero indicate that there no data occurs on the end that record. One indicate that one or more data errors occur on the record. When you take a look at this one, okay, the value is either one or zero. Okay, the n equals to 4. Here is the iteration counter. It means that since that this is observation, the first observation successfully created because there is no data error. The second one also successfully created. The fourth one, since that this will be an error, that's why this underscore n underscore will capture n will capture equals to 4. Okay, which iteration that actually the error occurs. Okay, based on this example, we demonstrate to you how such behavior when a data error occurs. Okay, when a raw data file is read, because this particular raw data files they have commonly they will have this kind of problem. Okay, so that's why uh, you have to make sure that the way on how you detecting the data errors is fully understand by you as the SAS programmer. Okay, right. So you can try to do this example. Okay, you use P108A01. Okay, and then you take a look at what are this P108A01 is about. Okay, so P1018. Okay, so non-sales. Non-sales, is there any data non-sales in PG1? Okay, so this is the one. So you just change the location. Okay, just change the location here. And then run. Okay, so okay, there is some errors here. Okay, and which statement best describe the reason for the error? Okay, so the error occurs because the programmer incorrectly read the data. Last was read as numeric, but this actually needs to be read as character. Okay, so based on this, when you take a look at the non-sales.csv, okay, so this is non-sales.csv. ID first and last. So last is should be the last name, correct? So last name should be character. So that's why you need to put $sign here. So when you read this, when you run this one, now you will not have this error. Okay, so that's why the answer will be B. Okay, because the last name was read as numeric but needs to be read as character. So uh, before you go for the next procedure, make sure that you correctly read the data. Okay, you successfully read data without any errors in your data set. Okay, to make sure that when you do the analysis, you will not have any issues. Okay, to do the analysis. Okay, all right. I think that's all for this first part. We will continue second part in our next video. Thank you for listening. Bye.